So this is a similar .search form that I showed last time. The only difference here is the sources and target. Here in my test documents, I have a collection of different document types. So I have a Word document, a PDF, an image, which is going to be the same as the PDF, which is just an image of the PDF, which I can show you right here. It's just a regular bank statement where we have a name and an account number. Those are the sensitive information, so to speak, within this particular document. Same thing with PDFs, exact same information. The only difference is that this is actual text that's embedded within the PDF. So you can do things like highlighting it, copying it, what have you. Word documents, fairly simple. It's just sort of like a bank statement just written out. You have two names that we want to anonymize here. And then Excel is going to be a tabular format over here. And it's just going to contain things like email addresses, social security numbers. I think those are the ones that we're going to be focusing on. You can also see atomic values, first and last name. And I can show you how you would be able to mask those using another path filter for specifically for tables, which is applicable for our CSV files, for Excel files, and also for relational database tables. And of course, again, here we have information, sensitive information that's embedded within free-flowing text within the comments field here. So we would be able to mask the social security number while leaving the rest of the field unmasked. Let's see. And yeah, the CSV file is just the same thing. So for the different matches that I have currently, I have the names matcher. I think we showed that last time with the NER, named entity recognition model. For the names, we're going to be applying format preserved encryption. Again, a similar concept as last time. I think what's new here is our date matcher and the social security number matcher. So social security number just uses our PIN-US data class, which is just a regular expression pattern matcher. For social security numbers, again, we're just going to be format preserving encrypting it. And then our date matcher is going to use our ISO date matching. And for that, we're going to perform a blurring on the date. So a blur function is just a way for us to specify how we want to add a random noise to a date. So, and also to things like ages or integers. So you can specify your minimum date, your maximum date, and the amount of days that you want to blur within that date. So it'll be plus or minus up to those number of days. So if you specify 60, you can either add 5 days or subtract 3 days. And the returned date will still be date format. So in ISO date in this case, it's good for things like databases where you have type restrictions on what can go inside of a column. I'll just go ahead and run this search and masking job on the test documents. Here it just gives you some log info, what it's finding, what's being annotated, and what's being remediated at any point in time. And when it finishes, you can see that some here are warnings. Like, for example, here it says for PDF specifically that it couldn't encode particular ciphertext in a font that's being used within the PDF. So it defaults to another font that it can use to do the encoding. This sometimes happens with PDFs in particular because a PDF only stores the font information that it needs to render the letters that appear within that particular document. So if that document never contained a character association for an X, it won't be able to encode that into the same font that it's using for all the other letters. In which case we just default to a font that we do have on hand by default and use that to encode the information. I'll go ahead and open up the mask data here. Oh, there we go. Yeah, just got to refresh it. Not sure why I didn't update. See, if I open up the JPEG here, so yeah, you can see that the name was masked. Part of the address here was masked. The primary account number, again, in each case was black box redacted. And that's specific to images. Images, no matter what masking rule you specified will only be able to produce a black bounding box for where the result was, since we can't just replace text with other text and images. What we can do for PDFs is actually replace, text with other text. So you can see that we format, preserve, and encrypted the name here and the account number as well. So it used to have some 5 zeros and then 9572 or something along those lines, but then was format, preserved, and encrypted across the entire document. So now it's a new account number encrypted. The bank document, that again, we have the two names that we're format, preserved, and encrypted. Same thing for XLSX and CSV files. I believe that I only matched on emails, social security numbers. Yep, so social security number was encrypted. Email addresses were hashed. And yeah, it also looks like I had a set file that is capable of detecting names in here and format, preserved, and encrypt in it. But you might not have a set file that can match every possible name. So I could show you another way that you can match on first name and last name specifically using a regular expression pattern and then just mask everything within, sort of like how FieldShield would do it, where it would classify first and last name and mask its contents. One thing I should have mentioned is the data class I'm using uses a combination of the named entity recognition model and the name sets. I just had a set file containing all those names, which is why I was mentioning that you might not have that set file. What I'm going to show you is how you would match on those names using the column name instead, right? So you can see that both the CSV Excel file have first name, last name, and that's what indicates that this entire column contains names. So similar to how in our JSON path filters, we used JSON path to match on a particular key, which we knew contained names, we can also do the same for tables. And for that, I'm gonna create a new search folder here. I'm going to specify the same directory, test documents. For our test documents, this time I'll only do XLSX and CSV. Let me find it here out of the list. You can also do something like include anything that ends with CSV, right, or XLSX, and that'll use as a regular expression pattern to match on the file name within that test document folder. But I'll just use the file types here instead. I'll go ahead and put it as mask2. So it will output it into another folder. Here I'll just select all of the metadata. And for our search matchers, I'm going to create a name filter matcher. This data class is just going to match on everything within our columns, right, within those columns. So dot plus means match any character one or more times. I clicked on cancel. I think we're going to use a format preserved encryption rule. I'll just recreate it here. For a filter, I'm going to select the table header pattern over here. And from there, what I can do is I can say dot star, which means match any character 0 or 1 times, and then name. So this will match things like first name, last name, or just name as a table header. And I'll click OK. OK again, and I'll finish creating this. So now, if I search our test documents, I'll only pick up CSV and XLSX because those are file types that I specify here. And it'll use this name filter matcher to filter on first and last name, and then format, preserve, and encrypt it. So go ahead and run this. And I'll open up the masked folder. You can see that our CSV and Excel file were created. And then you can see that, again, the first and last name columns were encrypted in the same way that we did it when we just were matching on set files. And same thing for the Excel file over here. There are two things that can happen with PDF specifically that might cause issues. So we do have, if I go really quickly go through the wizard here again, so I'll just put some random information here, a regular all with a redaction function. So if I click here, you can see that there's a PDF configuration page, which allows you to specify some options specific to PDFs. One of them is to search through embedded images, right? So if you had embedded images within your PDF, it'll be able to search and mask those images, embed them back into the resultant PDF file. The reason why it's a separate option for PDFs rather than for Word documents, which can also do the same thing, is that for PDFs, this might take a lot longer because of the way that how PDFs handle embedded images. If you know that you don't have any embedded images that contain any sensitive information, usually you want to deselect this particular option. Now, the other two options here are basically describing what would happen in the case of we have an encoding error. Now, encoding error is what we saw previously here, where it couldn't encode a particular ciphertext because it didn't have the glyph association with a particular set of characters. So, for example, if it was encoded in Arial font, right, that PDF will store all of the characters in Arial font, but it won't store the glyphs for characters that don't appear in that PDF. So if that PDF never contained an X, it's not going to store it within the PDF. So if we try to encode in the same font that was embedded in the PDF, and we're trying to encode an X, we won't be able to find that particular glyph association. So we default to Times New Roman. Now, sometimes you might not be able to encode it in Times New Roman either. So, for example, if you were replacing English characters with Korean text, we might not have glyphs in the system for Korean text, in which case we're going to get an encoding error because we don't know how to display those Unicode characters. If an encoding error happens, you can specify what will happen next, right? So one of the options is to perform a black box redaction on those characters instead. So it'll redact it within the PDF. Another option is to ignore it entirely, and that would just mean that information will remain unmasked. Search result will remain unmasked. Now, similar thing for text overflow. In PDFs, everything is drawn out like a canvas. So how it appears is how the PDF just drew it out. There's no concept of things like paragraphs or realigning text to fit new text. It's just someone took a paintbrush and drew those glyphs out on white canvas. So when we are doing some replacement of an original text with some ciphertext, that ciphertext can actually be longer than the original text, and we cannot guarantee that it won't overflow into other text because we don't automatically rearrange that text within the PDF. So in those cases, what we can do is, again, we can try a black box redaction instead, which will fit the area of the original text. We can try to truncate the ciphertext. Certain encryption algorithms allow you to truncate that particular text and it would still be sufficiently encrypted, although not reversible, which for PDFs, again, shouldn't really matter because you're probably not going to be able to reverse the text in the PDF anyway. And then you can also just replace it as is. So if you know, for example, that you have enough white space within that PDF to take the full entire ciphertext, you can specify that option. So those are specific to PDFs. Every other file format other than images can embed whatever ciphertext you give it and whatever font it's going to be displayed in.